Okay, so higher order derivatives just means that it's not the first derivative like we're used to taking. We're used to just finding f prime, or dy dx. Okay, we could also take the second derivative, the third derivative, the fourth. We could take the derivative as many times as we wanted, and so this would just be the nth derivative. We could take it 100 times if we really wanted to. Now we know that the first derivative tells us slope. Okay, the second derivative we are going to use here in calculus. I'm not going to quite tell you what that's for yet, but we will be finding the second derivative. And also the third derivative will tell us something as well about the graph. Each one tells us something different about the graph. Okay, so first, second, and third derivatives we will be using here. Fourth derivative, I'll be honest, I'm not really sure when you would use these. I don't remember from Calc 2 or Calc 3 in college or any of the higher math classes where you would use a fourth derivative or beyond that. But the first, second, and third are important. So this is really just, again, taking the derivative over and over again. So if they give me f of x and they want me to find f to the fourth, we just have to take the derivatives in order. So we would take the first derivative, f prime, and we would use our power rule. So this would become 9x squared minus 4x plus 4. And that's just using the rules that we had been using before. Now I can take the second derivative, f double prime. That's the way you say that, f double prime. Okay, and so again, I'm just going to use my power rules here on the first derivative. So now this will become 18x minus 4. And then f triple prime will just be 18, and then f to the fourth prime of x is going to be 0. Now everything beyond that is going to be 0 again and again and again. Now they only asked us to find f to the fourth, but if they had asked me to find f to the 10th, that's still going to be 0. Okay, you could just keep going on and on forever. Any derivative higher than that is going to be 0. So just as a rule, if you have a function, a polynomial, that's x to the n, if they ask you to find the derivative of anything, of anything above that exponent, anything that's higher, the derivative is going to be 0. Okay, so I can already see that's saying, like here, my highest exponent was 3, and they asked me for the fourth derivative. So I know my answer is going to be 0. So if I had, for example, let's say I had g of x is x to the 200th. Okay, if they ask me to find the 201st derivative, it's going to be 0. Anything above that exponent is going to be 0. So that's just a rule of thumb that you can always remember. Okay. So let's look at this next one. Now this one gets a little bit more complicated because we have the quotient rule to do. So I'm going to do the quotient rule first to find my first derivative. So I have bottom times the derivative of the top minus top times the derivative of the bottom. Low d high minus high d low over the bottom squared. And now I can simplify a bit. So I have x minus 1 minus x, which gives me negative 1 over x minus 1 squared. Now I'm going to take the derivative of that. So I'll choose a different color. So now g double prime is going to be bottom times derivative of the top, which is 0, minus top times the derivative of the bottom. Now, how do we find the derivative of this? Well, you would have to FOIL this out. So now I can see the derivative of that is 2x minus 2. All over the bottom squared. So x minus 1 squared squared. So this whole first term becomes 0. So I'm left with 2x minus 2 over x minus 1 to the fourth. And actually, this can be simplified. I know it doesn't really look like it, but I could factor a 2 out of this numerator. And you see I have x minus 1's. So this will become 2 over x minus 1 cubed. Now, the reason why I went through that problem so quickly, and I know I did go through it quickly, is because all of that algebra stuff here at the bottom, that's not new. The only new thing is, oh, we're taking the derivative a second time. Okay, so all of the rules and all of the algebra and everything, that's all old. That's all stuff that you should know how to do. The new piece is just taking the derivative a second time. So that's why I was going through it kind of fast. So for this next one, they're asking me to find the fifth derivative, but they give me the fourth derivative. Okay, so if they give you the fourth and they're asking for the fifth, you only have to take the derivative one time. So the fifth derivative is just going to be 1x to the negative 1/2. Okay, so you have to pay attention to what they are giving you. Okay, if they give me the original function, then yes, I would have had to take the derivative 5 times. But they're already giving me the fourth derivative, so you only have to take that derivative once. Okay. My phone is ringing. Hold on a second. Okay, I'm back. Sorry about that. I don't know if you could hear the phone ringing in the background. Okay, anyway. So now they want us to find f triple prime of -1. So we've done this before. You're going to find f triple prime of x, and then just plug in -1 when you're done. So first I'll rewrite this to be 2x to the negative first, because remember, anything in the denominator gets a negative exponent. So now the first derivative will be negative 2x to the negative second. The second derivative will be positive 4x to the negative third. And then triple prime is going to be negative 12x to the negative fourth. And this is the one that we want to plug -1 into. So I'm going to rewrite it as negative 12 over x to the fourth. Just because when I plug things in, I think that's easier for me to have positive exponents and not negative exponents. So I'm going to have negative 12, I shouldn't write it like that. I'm going to write it like this. F triple prime of -1 is going to be negative 12 over -1 to the fourth. So it's going to be negative 12 over positive 1, which is negative 12. Okay? All right, so the next one here, okay, I want you to try on your own. However, okay, I know that you see two things here and you might think, oh, I'm going to do the product rule. You can absolutely do the product rule. You have f double prime here, so you can do the product rule and then take the derivative again. Or you could FOIL these and then take to the derivative again. I'm going to show you both ways after I give you a chance to try it yourself, but whichever way you feel more comfortable doing it. So you can FOIL first and then take the derivatives, or just leave it like that and use the product rule and take the derivatives that way. It's up to you. So find the second derivative and then plug in 5. So go ahead and pause the video, give that a shot, and then we'll see how you did. Okay, so here's your two options. The first option is by FOILing first. So I FOILed these 4 together, and this is what I got. Then I took the first derivative, second derivative, and then plugged in 5 to get 108. Over here, I wanted to start it even with this one, because it was the first, so I kept them as the same color. So this is taking the first derivative. So it ends up being one extra step that this side didn't have to do. This side you had to FOIL first and then take the derivative. This one you could take the derivative right off the bat, but then you had to do some combining like terms and simplifying to get to your first derivative. So we took the product rule. So this was first times the derivative of the second plus second times the derivative of the first. Then you just distribute and combine like terms, but you can see that they are equal. You do get the same thing, no matter which way you do to get the first derivative. Then your second derivatives are the same, plug in 5, you get 108 for whichever method you used. But the answer should be 108. Okay, now let's look at trig for just a moment. Okay, my trig function here is just cosine. Okay, so now before I even look at this, what they're asking me to find, if I find the first derivative of cosine, the derivative of cosine is negative sine. Then if I find the second derivative, the derivative of sine is cosine. And that negative stays out front. The third derivative is going to be negative sine, which is just positive sine. And the fourth derivative is back to cosine. Okay? Notice they're the same. The original function and the fourth derivative are going to be the same. It's going to go through the same cycle. So the fifth derivative is going to be the same as the first derivative. And then the sixth will be the same as the second, and the seventh will be the same as the third, and the eighth will be the same as the fourth. So if you have just sine, and this works for cosine as well, every 4 derivatives that you take, you're going to get back to the original function. Okay, and if you think about the waves, I don't know if you remember this, but the very beginning when we talked about trig functions, I showed you the sine wave, and we talked about the slope, and then we saw that it was the cosine wave. That's just going to keep going back and forth between the two waves. The slopes are going to be the same because the waves are nice and uniform, so the slopes are just going to keep going back and forth between all the waves. So just remember that each fourth derivative is going to circle back to the original function. And that works for anything that's involving just sine or cosine. Not if you're adding anything or anything like that, but just sine and cosine, that's what will happen. And it would even happen if, let's say you started at, let's say this was your original function, negative sine of x. Well, then the fourth derivative would again be negative sine of x. Okay, so it works for positive or negative sine and cosine. Every fourth derivative is going to be the same. So now let's find out what they're asking us for. Fourth derivative, g to the fourth of pi over 6. It's going to be cosine of pi over 6, which is square root of 3 over 2. Okay, so the last two there, okay, you have 2 to find, f double prime of negative 2 and g double prime of pi over 4. Okay, so I want you to find the second derivatives of both, then plug in that value and see what you get. I will tell you the trig one is a little bit tricky. Let's see if you can figure it out. Don't forget that the derivative of secant is secant tangent. We talked about that in class yesterday. So just remember that when you are doing this. But see if you can figure these two out. Pause the video, and then we'll see how you did. All right, so the first one I went through, and first I I distributed. I did that to get this. And then I took the first derivative, second derivative, plugged in negative 2 and got negative 48. This down here, I just wanted to show you, is doing the first derivative by taking the product rule. So just like that last example that we did, you could have used the product rule here, with 6x being your first function and 2x plus x squared being your second. So first times derivative of the second plus second times the derivative of the first, you'll see you do get the same thing that I got up here by distributing. So there you go. Whichever method you did, you still should get negative 48. Now for this one, if you got this trig one, I would be thoroughly impressed. This one is very difficult. Okay, so the first derivative, okay, the derivative of secant is secant times tangent, and then the derivative of sine is cosine. That part hopefully was simple and you got that. But taking the second derivative, now I have to use the product rule here. Okay, so the product rule tells me first times the derivative of the second, so the derivative of tangent is secant squared, plus secant times the derivative of the first, which again is secant times tangent. And then the cosine, you find that derivative on its own, and the derivative of cosine is negative sine. So then I just simplified it a bit. This would become secant cubed, and then secant times tangent squared, because there's two tangents. And then I plugged in pi over 4. Secant of pi over 4 is square root of 2, tangent of pi over 4 is 1, and sine of pi over 4 is square root of 2 over 2. So again, you do need to know all your unit circle values here. So then simplifying it a bit, square root of 2 cubed becomes 2 square roots of 2. Squaring the 1 is just 1, so this just stays square root of 2. And then that one, I'm going to keep it that way for now. Then I got a common denominator. So I had to multiply this by 2 and this by 2 so that they all had the common denominator. Then we can combine like terms. All of these have a square root of 2, so I can just treat them like variables. So 4 plus 2 is 6, minus 1 is 5 square roots of 2 over 2. Like I said, if you got that last one, I would be very impressed. That one's very difficult. Okay, but really the only thing you need to take away from these notes is finding higher order derivatives, which means just taking it a second or third time. There is a little homework assignment with this. There are 10 questions, and it's just, again, finding the derivative second, third, or fourth. There are 2 at the bottom where you are plugging in a value, 9 and 10. You have to plug in a value, but they're not that difficult. Nothing on that practice paper is as difficult as this trig function one that we just did. Okay. If you have any questions, I will answer them on Thursday's class before we take the new set of notes. Or you can shoot me an email today and we could talk about it if you needed to. Okay, thank you for watching.